Bismillahirrahmanirrahim. Welcome to my video presentation. Topic of my presentation is silver. Now let me move about my introduction. My name is Minahil Afzal. I am a student of BS Biotech. Let me introduce to the contents of my presentation. Introduction, history, discovery, properties, method of mining, value of silver, chemistry of silver, reaction of silver, application of silver, effects of silver. Introduction. Silver Ag, chemical element, a white lustrous metal valued for its decorative beauty and electrical conductivity. Silver is located in group 2 and period 5 of periodic table between copper and gold, and its physical and chemical properties are intermediate between these two metals. Here is the picture that shows silver. Now let us talk about the atomic number of silver. The atomic number of silver is 47. History of silver. Silver was first mined around 3000 BCE in Anatolia, now located in modern-day Turkey. The precious metal helped early civilization in the Near East, ancient Greece to flourish. History. Historically, a major use of silver has been monetary in the form of reserves of bullion and in coins. The demand for silver for industrial purposes in particular and photographic industry exceeds the total annual production. Explanation. During the 1900th century, new mining techniques contributed to a massive rise in overall silver production. Breakthroughs included steam-assisted drilling, mine dewatering, and improved haulage. Further advances in mining techniques enhanced the ability to separate silver from other ores and made it possible to handle larger volumes of material. Discovery of silver. Naomi Cardona Gonzalez, Matthew Burkastras learn about silver and understand why silver symbol is Ag. Study the Ag element or silver on the periodic table and discover the many uses of silver. Occurrence of silver. Occurrence. The abundance of silver is 0.08 parts per million in the Earth's crust. It is almost exactly the same as the mercury. Silver mostly occurs in the sulfide ores, especially athentites and arginite Ag2. The metal is found in Earth's crust in the pure free elemental form as an alloy, and gold and other metals in the minerals such as arginite and chloride. Where silver is found in nature. Silver is found in nature in both native and combined states. Silver is less reactive than other metals. Native silver occurs as elongatic dendritic coatings in irregular masses. It may occur alloyed with gold and electrum. It often occurs with silver sulfide and sulfur salt minerals. Properties of silver. Silver has a shiny appearance and a great conductor of electricity. It is also known for its high thermal conductivity and resistance to corrosion. Plus, it is often used in jewelry and silverware because of its beauty and durability. Methods of mining. There are new methods which are critical to increased volume of production, as many of the high-grade ores throughout the world has been largely used up by end of 19th century. More than 5,000 years after ancient culture first began to mine in relatively small amounts, silver mine production has now grown to almost 800 million ounces in 2019. Values of silver. Silver has long been valued as a precious metal. Silver metal is used in many billion coins, sometimes alongside gold. While it is more abundant than gold, it is much less abundant than native metal. Its purity and typically measured on a per mile basis as 94% pure alloy is described as 0.940 fine. As one of the 7 metals of antiquity, silver has had an enduring role in the most human cultures. Etymology. The chemical symbol Ag of the Latin for silver, argentum, from the Proto-Indo-European root meaning white or shining. This was the usual Proto-Indo-European word for the metal whose reflexes are missing in Germanic and Balto-Slavic. Chemistry of silver. Silver is rather reactive metal. This is because it is filled with 4D shell and it's not very effective in shielding the electrostatic forces of attraction from the nucleus to the outermost 5 electron, and hence silver near the bottom of the electrochemical series. In the group 11, silver has the lowest first ionization energy. Reactions of silver. Silver metal is attacked by strong oxidizers such as potassium permanganate, potassium dichromate, and the presence of potassium bromide. These compounds are used in photography to bleach silver images, converting them to silver bromide that can either be fixed with thiosulfide or redevelop redevelop to intensity the original image. Silver forms cyanide complexes that are soluble in water in the presence of an excess of cyanide ions. Silver cyanide solutions are used in electroplating of silver. Positive ion plus chloride which contain negative ions will give us silver chloride. Silver chloride plus chloride ions will give us silver sulfide that contains two chloride ions. Silver has also been shown to readily react with sulfur in water. Free silver ions will react with sulfur in the water to form the precipitate silver sulfide. Silver and sulfur reaction in seawater. 2 moles of silver plus H2S will give us the sulfur sulfide plus hydrogen. Oxidation reactions of silver. Possible oxidation reactions of silver are as follows. Silver plus oxygen will give us silver ion plus oxygen 2 negative. 4 sulfide ions will give us, by reaction with water, will give us 4 silver ions plus 2 oxygen ions. In aerobic acidic seawater, oxidation of silver can occur through the following reactions. Oxidation of silver in seawater. 2 silver ions plus half mole of oxygen plus 2 hydrogen ions will give us 2 silver ions plus water. This solution of silver dioxide ions in water. Ag2O plus water will give us 2 silver ions plus 2 hydrogen ions. The common oxidation states of silver are plus 1, the most stable state, for example, silver nitrate, AgNO3, plus 2, highly oxidating, for example, silver 2, chloride, AgF2, and even rarely found, plus 3, extreme oxidating, for example, potassium tetrafluorogentate, KgF4. Applications of silver. There are many applications of silver. The detail of silver's application are as follow: medical field, electronics, jewelry, pressing alloy, chemical equipment, catalysts, photography. Medical field. In medicine, silver is incorporated into wound dressings. It is used as an antibiotic coating in medical devices. Wound dressings containing silver sulfadazine and silver nanomaterial are used as treatment of external infections. Medical applications. Medical applications of AG and PFS focusing on antimicrobial and anti-cancer properties and potential mechanism, as well as other medical applications including wound repair, bone healing, dental applications, vaccine, adjuvant, antibiotic agent, and biosync. Reasoning. Silver has antimicrobial properties, making it effective against broad spectrum of bacteria, viruses, fungi. In the medical field, this property is utilized in various forms such as silver-coated dressings, catheters, and wound care products to prevent infection and promote healing. Additionally, silver nanoparticles are being explored for their potential in medical applications due to their unique antibacterial properties. Applications in electronics. Silver boasts numerous benefits, including the best electrical conductivity of all metals, stellar choice for manufacturing electronic components such as printed circuit boards, TV screens, microwave ovens, and many more. Silver is a perfect metal for coating electric contacts. Almost everything around the contains traces computers, of appliances, and electrical switches. In recent years, silver has been used to coat it Nanomaterial surfaces to contain an electrical pathway without needing wires. Jewelry. The major use of silver besides coinage throughout most of the history was the manufacture of jewelry and other general use items, and thus continues to the major use today. Reason. Silver is popular for jewelry due to its lustrous appearance, affordability compared to gold, and versatility in design. If it doesn't tarnish easily, making it practical choice for everyday wear. Additionally, some people prefer silver for its hypoallergenic properties, making it suitable for those with metal sensitives. Uses. These uses include table silver for cutlery, for which silver is highly situated due to antibacterial properties, Western concept flutes, and usually plated with or made out of sterling silver. In fact, most silverware is only silver plated rather than made out of the pure silver. The silver is normally put in place by electroplating. Silver plated glass is used for mirror, vacuum flask, and Christmas tree decorations. Electronic silver is very important in electronic for conductors and electrodes, and on account of its high electrical conductivity even when tarnished. Bulk silver and silver foils are used to make vacuum tubes and continue to use today in manufacture of semiconductor devices, circuits, and their components. Example, silver is used in high quality contractors for RF, VHF, and high frequency, particularly in tuned circuits such as cavity filters, where conductors cannot be scaled by more than 6%. Printed circuits in RFID antennas and made with silver paints. Powdered silver and its alloys are used in paste preparations for conductor layers and electrodes, ceramics, capacitors, and other ceramics components. Nanoparticles. Nanosilver particles between 10 and 100 nanometers in size are used in many applications. They are used in conductive inks for printed electronics and have much lower melting point than larger silver particles of micrometer size. They are also medically in antibacterial and antifungals in same way as much as larger particles. In addition, according to the European Union Observatory for Nanomaterials, silver nanomaterials are used both in pigments as well as in cosmetics, photography. Photosynthesis of silver halides allowed for use in traditional photography, although digital photography which does not use silver is not dominant. The photosynthesis emulsion used in black and white photography is a suspension of silver halide cluster in gelatin, possibly mixed with some noble metal compounds for improved photosynthesis developing in tuning. Example, color photography requires the addition of special dye components and sensitivities, so the initial black and white silver images couples with a different dye components. The original silver images are bleached of silver and recorded and recycled silver nitrate in the starting material in all cases. Catalysis. Silver metal is a good catalysis for oxidation reaction. In fact, it is somewhat too good for most purposes, and finely divided silver tends to result in complete oxidation of organic substances to carbon dioxide and water. And hence, coarser grained silver tends to used in incense. For instance, 15% of silver spotted on Ai2O3 or silicate is used as a catalyst for the oxidation of ethylene and ethylene oxide at 230 to 270 degree temperature. Dehydrogenation of methanol formaldehyde is conducted at 670 degrees Celsius over silver gauze and crystals at the catalyst, as if dehydrogenation is pronal to acetone in the yields glycol and ethanol yield acetaldehyde, while organic amines are dehydrated in nitriles. Chemical equipment. Silver is used in manufacture of chemical equipments on account of its low chemical reactivity, high thermal conductivity, and being easily workable. Example, silver crucibles alloyed with 0.15% of nickel and avoid recyclation of the metal at the red heat and used for carrying out alkaline fusion. Copper and silver are also used when doing chemistry with fluorine. Equipment made to work at high temperature is often silver plated. Silver and its alloy with gold are used as a wire or ring seals for oxygen compressors and vacuum equipments. Brazing alloys. Silver containing brazing alloys are used for brazing metallic materials, mostly cobalt, nickel, and copper based alloys, tool sheets, and precious metals. Examples. The basic components of silver are copper and with other elements selected according to the specific application desired. Example, zinc, tin, cadmium, palladium, magnesium, phosphorus, silver provide increased workability and corrosion resistance during usage. Effects of silver on different fields. Silver effects on human. Several factors influence the ability of a metal to produce toxic effects on the body skin. Contact occurs in occupational settings from the application of burnt creams and from the contacts with jewelry. Silver can also gain entry in the body through the use of acupuncture needles, catheters, dental amalgams, or accidental punctures wounds. Agrosis and argyria. The most common health effects associated with prolonged exposure to silver are development and characteristics irreversible pigmentation of skin. The affected area becomes lush gray or ash gray is the most prominent in the area of the body exposed to sunlight. Here are some examples of some patients suffering with
Types of argyria and argiosis. Localized argyria is caused by direct external contact with silver. Very small silver particles may enter the body through the exocrine sweat glands or through punctures. Generalized argyria. Generalized argyria is recognized by a widespread pigmentation of the skin, eyes, and nails. Generalized argyria and arteriosis may result when silver compounds are applied to mucosal surfaces inhaled, ingested, or injected into the body. Results you can see metabolisms. Ingested silver compounds are estimated to be absorbed by the body at a level of at most 10%, with only 2 4% being retained in tissues. Silver can be measured in urine, blood, and feces, even though the body eliminates silver primarily in feces. It can be accurately determined in whole blood and is therefore the biological medium of choice due to collection convenience. Urine, Urinary analysis is useful only following a high degree of exposure because little silver is excreted in urine. Respiratory disorder. Inhalation of soluble silver compounds has been reported to cause both upper and lower respiratory tract irritation, although irritation is most likely caused by the corrosion effect of nitrate in some silver compounds rather than by silver itself. Restriction of alveoli. Staining of alveoli and bronchial tissue may occur after inhaling silver dust or fumes, but this apparently is not harmful to health. However, bronchitis, emphysema, and a reduction in pulmonary volume were observed when silver polishers were exposed to metallic silver as well as to other metals. Tissue and organs. Normal concentration of silver in human tissues are low. If there is overexposure, silver can accumulate in the skin, liver, kidneys, corneas, gingiva, mucous membranes, nails, and spleen. Silver ions possess a high affinity for the thiol groups in the liver and have been shown to bind to reduce glutathione and be transported into the bile, thus depleting the amount of reduced glutathione available for biochemical pathways. Effects of silver on environment. The most environmentally relevant species of these nanoparticles are silver chloride within marine ecosystems and organic thiols within terrestrial ecosystems. Once Ag negative enters the environment, it is oxidized through Ag positive of the potential species formed in seawater, such as Ag2S and Ag2CO3. AgCl is the most thermodynamically favored due to its stability, solubility, and the abundance of chlorine negative in seawater. Research has shown that partially oxidized nanoparticles may be more toxic than those that are freshly prepared. Side effects of silver on bacteria. Silver nanoparticles are experimentally shown to inhibit autotrophic nitrifying bacterial growth more than Ag positive ions are AgCl colloids. Silver nanoparticles inhibited heterotrophic growth in Escherichia coli is best observed at lower concentration between 1.0 um and 4.0 um. Effects on aquatic environment. These free-formed Ag-positive ions can accumulate and block the regulation of sodium-positive and chlorine-negative ion exchange within the gills of fish, leading to blood acidosis, which is fatal if left unchecked. Additionally, fish can accumulate Ag through their diet. As fish eat phytoplankton, the silver accumulates within their circulatory system, which has been shown to negatively impact embryonic fish, causing spinal cord deformities and cardiac arrhythmia. Effects of silver on plant growth. Nanotechnology effect on plant growth. Nanotechnology is the most advanced and rapidly progressing field of science and technology. It primarily deals with developing novelty in nanomaterials by understanding and controlling matter at the nano level. Silver nanoparticles. Silver nanoparticles are the most prominent nanoparticles incorporated with wide-ranging applications owing to their distinct characteristics. Methods of synthesis of silver nanoparticles. There are three methods of synthesizing silver: chemical method, physical method, protochemical method, and last one, biological method. Chemical method. Chemical method is an effective wet chemical method for making zero-valent nanoparticles based on chemical reducing aqueous salts of metals such as silver nitrate in the case of synthesis of silver nanoparticles for example, to reduce the precursor metal salt, at least one reducing agent is used to produce electrons for metal ions that reduce them to become zero valent. Commonly used reductants are borohydride, citrate, etc. Physical method is evaporation, condensations, and laser ablation are the most important physical approaches. The absence of solvent contamination in the prepared then films and the uniformly of NPS distribution are the advantages of physical synthesis methods in comparison with chemical process. Protochemical methods. Protochemical processes have gained significant attention in the fabrication of metallic NPS due to the enhanced spatial and temporal control these techniques offer. A typical experiment exposes solutions containing the metal precursors to visible or ultraviolet light. Advantage of protochemical method. As compared to other methods such as chemical methods, protochemical routines in nanotechnology are advantageous as they avoid the use of toxic or harmful compounds, do not rely on expensive instrumentation, are highly skilled personnel, and most importantly can be carried out at ambient conditions, i.e., room temperature and atmospheric pressure. Biological methods. For the synthesis of nanoparticles, plant extracts are used as reducing agents, and it has greater advantage over biological process because of the fact that they eliminate complex cell culture and maintain processes. Biological methods. There are many ways of synthesizing silver nanoparticles for biological methods such are as follows: yeast, fungi, and bacteria. Here, let's see the pictures of fungi, yeast, bacteria, viruses, antinomicides, algae. Biosynthesis of nanoparticles using different microorganisms in different fields. Bacteria in nanoparticle synthesis. Silver nanoparticles synthesized by using Bacillus brevis have recently demonstrated remarkable antimicrobial properties against uh, Staphylococcus aureus and Salmonella typhi multi-drug resistant strains. Pseudomonas streptorhizae is another bacterial strain which has been found to accumulate AgNPS through an intracellular mechanism. In Bacillus, silver nanoparticles have also been synthesized in intracellular periplasmic space. Fungi in nanoparticle synthesis. The biosynthesis of nanoparticles fungi are comparatively more resourceful than bacteria due to many bioactive metabolites, high aggregations, and improved production. Several filamentous fungi have been reported to be capable in AUNP biosynthesis. In order to biosynthesis AUNPS, this study employed various methods. The authors suggested that fungal secreted compounds and media components could be used to stabilize the nanoparticles. Yeast in nanoparticle synthesis. Yeast strains of several genera are now used to employ different mechanisms of nanoparticle synthesis, resulting in significant variations in size, particle positions, monodispersity, and other properties. One study found that glutathione and two classes of metal binding ligands, metal thionines, and proto Claytons were generated by detoxification mechanisms in yeast cell. These molecules have a role to play in deciding the mechanism for nanoparticle synthesis and stabilizing the resulting complexes in most of the yeast species studied. Effects of silver on industry. Silver has many industrial uses accounting for more than half of annual demand worldwide over the last 5 years. This means that economic growth can affect silver prices far more than it affects gold. Only 10 to 15% of annual gold demand worldwide comes from industrial use, the rest going to jewelry and silver investment. Big consumer of silver for industrial applications. The big consumers of silver for industrial applications this past decade have been the US, Canada, China, India, Japan, South Korea, Germany, and Russia. Or that silver demand for older industries has failed only to be placed by new technological use. Positive impact of silver. Impact on agriculture. The positive impact of silver nanoparticles have been observed in various economy based sectors, including agriculture. The scientific curiosity about AGNPS in agriculture and plant biotechnology has shown optimum efficiency over the last 5 years. It not only enhances seed germination and plant growth, protection from silver. Re- Recommendation by government. The EPA recommends that the concentration of silver in drinking water not exceed 0.10 milligrams per liter of water because of the skin discoloration that may occur. The EPA requires that spills or accidental release of 1,000 pounds or more of silver be reported to the EPA. The Occupational Safety and Health Administration limits silver in workplace air to 0.01 milligrams per cubic meter for an 8-hour work day, 40-hour work week. The National Institute of Occupational Safety and Health also recommends that workplace air contain no more than 0.01 milligram silver. Bookmarks. Thank you so much.